E-flight-expo, making aviation greener since 2009.
E-flight-expo at AERO 2024. Cargo, Medivac, leisure, the first use cases for eVTOLs, because I think everybody who's interested in aviation has heard that about electric aviation and eVTOL happening soon, and it takes, especially on the eVTOL side. So more and more the developments which we have seen recently is that eVTOL will probably not come at the air taxis as we expect, but I will start a little bit more later, get my guests seated, and then we are sure we can give you a nice view over this interesting field of the first uses of eVTOLs. So I start again. I have to look at my watch. We don't want that people know. We still have 2 minutes to go. So I can give you a little bit update on the E-flight-expo in general. When you just come in, it's on the right-hand side here, the hangar with all the electric stuff. But don't miss it. There are also there is more electric stuff. In a lot of other halls, and for this we have done guide through all the electric stuff, which is in our E-flight journal magazine, where you will also find more information on the vehicles, and we will talk about here. And here you have a guide with all the halls, and it's marked all the electric stuff inside. You can have this magazine online, and you also can have it in a printed version. I have some copies over here, so you can grab one later. And we've done this together with AERO to give you an overview, because it's so many things you will see which are going electric now that we have to make this guide so that you don't miss the good things. If you miss anything, we'll report in our magazine also afterwards. And with this, I already nearly started, so I go to the next slide, which is giving you a little bit overview of what I'm doing, why I'm here, and why my guests are here, to give you an update on what's happening in the world of e-flight, eVTOL, and sustainable aviation in general. We have, on the other hand, the magazines, which you see up there, because that's was my primary job before I started the electric exhibitions and events, which are getting more and more time. We do several magazines, and we started the big one, which is the World Directory, which is published in German, English, French, and Chinese. And there you get most of the available aircraft you will find there. It comes out once a year, available at our booth here. And with the E-flight journal, we publish together with the AERO fair for this fair, and with other fairs around the world when there are electric events as well. And like said, if you don't want to carry paper, you can scan the QR code, and with the QR code then you can download the PDF for free of the magazine. With this, I go repeat our subject of the first discussion. The first discussion is about the first use of eVTOL. To explain a little bit more what's in the title we have Medivac, which is using this for rescuing people, for helping people, which I think is also a very important case because social acceptance for eVTOL will be very important for any use case we have. The second use case, which is cargo, which will be probably or most likely much before there will be any passengers flying for transport reasons. And the last use case is the use case of leisure. We don't have any leisure eVTOLs flying in Europe yet, but in the United States one company has just started. We have them here. They changed their name, and you will hear about this later. So I can go back myself. So we start now with Avilus, that's on the right hand side, and we have Nicolas and Max, and Max is going to give the presentation on, here is for advancing the slides. So I suppose, I don't know if you want to stand up or if you want to stay in seat, you can do like you want. Yeah, the stage is yours, and if you just press the forward button, your presentation should start. A big one, big green one in the middle. Oh, one more? Yeah, here we go. UAV grill.
So, hello everyone, my name is Nicolas. Hello? So, hello everyone, my name is Nicolas. I'm part of the management team of Avilus and one of the co-founders.
Hi, my name is Soepper, also a co-founder of Avilus and also part of the management team. So, to give you a quick introduction of who Avilus is, it's a quite young company, it's approximately 3 years old as the idea of the German armed forces to have a flying stretcher. What you can see here on the picture, it's already 1 year old. This is the team that was there when we had our maiden flight with the first aircraft. Back then we were approximately 30 people, now we've almost doubled the team, we're approximately 50 people now. As Medivac is a very special use case for eVTOLs, we would like to go a bit into the problem that we are solving. And the main issue in medical evacuation is that the main thing that counts is the time that the wounded soldier gets to the surgeon. We always say time is the best medicine. There are studies showing that especially for example, gunshot wounds, 10 minutes of delay to get to the surgeon can cause 3 times likelihood of death. And these are very, very clear numbers, and this is the challenge that we always face in medical evacuation, that we must be fast. When we look at the modern battlefield, for example, from what we see in Ukraine at the moment, we have some challenges that make it really hard for us to be fast. So the first thing is that the battlefield is super transparent. We have drone surveillance, the enemy knows perfectly where your assets are. Second of all, there is high precision weapon systems, loitering ammunition for example, that lead to the fact that the enemy can easily fight and attack your assets, which means that in the war zone you don't want to place any surgeons, so you have to move them back. And the third challenge is that you have electronic warfare going on, also for example CBRN threats, which make this war zone a really challenging environment. And all these facts make it really hard with the standard assets to rescue people, because you have to have the surgeons far back, which means that the evacuation time increases. And then of course a very obvious solution is to use drones. What is important for these drones is many things. So first of all, we just talked about it, this war zone is super dangerous for people. So you don't want to have people in there. This is why these systems must be unmanned. Second of all, you always have to calculate that you lose these systems. So these systems must be cheap, you must have many of them, and they must be easy to operate. So the operational complexity must be low. What does this mean? First of all, for flying these systems, they must have a high degree of autonomy that few people can fly these systems. We always say that 2 people should be able to operate 10 to 20 drones. At the same time, when you have just 1 or 2 people operating 10 to 20 drones for flying them and dispatching them, also the maintenance part of the operation must be low. So also low maintenance or almost no maintenance is a really important requirement if you want to be effective in this use case. The solution to all these problems, or one solution to all these problems, is our aircraft, the Grille. What you can see here is a test flight that we did in terms of an operational experimentation together with the German Armed Forces last fall in Munster. The Grille is an eVTOL. You have 6 batteries, 12 engines. It can go up to 90 kilometers per hour. Has a range, or we say radius because we go back and forth, of 30 kilometers. We have approximately 750 kilograms of maximum takeoff mass, and the system fulfills all the requirements that we just spoke about. So it's unmanned, or unpiloted, it flies completely autonomous or fully automated the mission. No maintenance is also a very important requirement for us. All the lift thrust units, for example, can be easily dismounted and plugged in again without any tools. It's basically plug and play. This is a really big advantage of the eVTOL technology that we use, and this is also one of the reasons why it's an eVTOL. Also the safety aspects of eVTOL come into play with the distributed electric propulsion. We have 12 engines, especially in this hot zone war environment. It's always good to have many redundant motors that you can use.
Maybe just to add, since the question always arises, when do you build the full-scale prototype? This is actually the full-scale prototype, so the diameter is 8 meters, and you can definitely meet us right around the corner at our booth and have a look at the new aircraft.
What you saw here is what we call 9X01, the first aircraft that has been flying already, and what we finished for the AERO. I don't know how good the picture here is. As Nicolas mentioned, you can see it better at our booth, which is right over here. Is the second aircraft that we can then show you and explain you all the technical details right there. Thank you.
Okay, thank you very much, Max. And yeah, I'm sure there are some questions. I already have some, but our format is that we first have all the presentations and then we can have questions either from the podium, from one to the other speakers, or from you in the audience. So stay tuned here. If you have questions, you have the chance to ask them at the end of the call. The next speaker, coming not as close as the team of Avilus, which is near Munich. They are coming now from United States, and Sky Sartorius, he is introducing us the Go AERO program. It's brand new, was announced this spring. It goes in the same direction, and you will see people around the world thinking on Medivac. So, Sky, the stage is yours.
Thanks. So I'm Sky Sartorius. I work for the Boeing company, Boeing Commercial Advanced Concepts, and today I'm here representing Go AERO. Boeing is partnered very closely with Go AERO. Go AERO is a competition, a prize that we launched in February of this year, and we're here to spread the word and build some excitement for participation.
We see heroes every day. Heroes who look past danger to help people in need. Heroes who step in to be the difference between triumph and tragedy. And heroes who use their minds to create technology that saves lives. We need those heroes. We're launching a new prize competition for a singular mission, saving lives. More than $2 million in total prizes is on the line for the best thinkers, creators, and inventors to stretch and challenge their minds, to change the way we reach people in the face of disaster, unlocking a new era of rescue response. An era that unleashes the power of autonomy, speed, and precision. Alongside NASA and Pratt & Whitney, Go AERO is looking for the brightest, boldest, and bravest innovators to change the way we rescue and respond to disaster. This is your chance to make history and save lives. Join us. Ready, set, go AERO.
So that was our little introductory video, but as you can see, it's a competition, a prizing competition with a couple $1 million of prizes on the line, and it's all surrounding the theme of public good missions. And this is the broader category of public good missions. It could be Medivac, it could be disaster response, firefighting, whatever it may be. And so what we've done is we looked at all of those public good missions and identified certain skills that we could test in the format of a competition that takes place over the course of a long weekend. So in a few years, we'll be hosting this competition, and we'll be asking teams who show up to perform 3 missions. So we have a productivity mission, an adversity mission, and a maneuvering mission. I'll go into a little bit more details on the next chart. But these are to be performed by nominally single-occupant aircraft, and these are all uncrewed aircraft at the competition itself. So the stand-in for the occupant is a 125-pound or 57-kilogram mannequin. And that mannequin can represent whatever the team's use case might be, whether it is an injured patient, or it could be a first responder or a firefighter, or it could be for bottled water in a disaster relief sort of scenario, whatever it may be. The 3 missions we have, there's a productivity mission, and this one's actually 2 parts, where we're asking teams, partially because there are many use cases where it's beneficial, and also partially because it's helpful for the logistics of the competition. Teams need to have a system that can be put on a truck or a trailer in order to show up at the competition. So part of the productivity mission is showing that you can go from that form factor to a flyable state relatively quickly. And then after that, it's about moving payload from A to B. In this case, A and B are co-located because you have to repeat this over and over again for 90 total minutes, so an hour and a half. And the winner of that mission is based on who's able to move the most cargo in that time. But that score is normalized by the total weight of your overall system. The adversity mission is just about showing that your aircraft is robust to different difficult conditions. So it's whether landing in a sandy environment, windy, rain and water, unsurveyed sites, sloped hills, things like this. And that's just the fastest team who's able to demonstrate that they can go land and take off in each of those different areas. And then finally, the maneuvering mission is about maneuverability, but also obstacle avoidance, where this course that's shown in the lower right of the chart is basically a slalom course with various obstacles flown forwards and backwards with and without that 125-pound mannequin on board. And so the best aggregate performance in each of these missions wins the $1 million top prize. And for each of these missions individually, there's a $150,000 prize. So some teams may choose to specialize in one of these and just go after one of those missions, and other teams will choose to go for the overall top prize. So what I've just described is that stage 3 in the first quarter of 2027, that fly-off, where there will be that $1 million top prize and those 3 other prizes, and also a couple of additional prizes that are rewarding autonomy or particular disruptive technology. But Go AERO it has 3 stages total to it, and so those earlier stages are what's coming up a lot sooner. So stage 1 has 10 prizes that will be awarded of $10,000 each. This is based on a digital submission of a design report and plan. Stage 2 is next summer, where teams, in addition to saying here's our design, here's our plan for the competition, they need to build a subscale prototype at least. It could be full scale, but on the order of Part 107 compliant, less than 25 kilogram gross weight. And then finally, we'll get to that final fly off in stage 3. Go AERO is has a very large network of sponsors and partners. So Boeing is, of course, a big sponsor, also Pratt & Whitney, RTX, NASA, X-Wing, many others. And then finally, just partner organizations all over the world. It is a very international competition, and we welcome teams to participate from pretty much anywhere and everywhere, and encourage everyone to do so. If you notice, especially the stage 1 competition is a very low barrier to entry to get started in the competition. So I would encourage anybody who's just curious to go to the website, herox.com/goaero, to check it out. You can read all the details of the rules, anything that I haven't covered or the Q&A session doesn't answer. And yeah, form a team. Go after some of that prize money.
Okay, thank you very much. It's quite interesting to see how different approaches can accelerate the system. And I remember there was also a prize, the first time NASA sponsored a prize for electric flying, which was a green flight prize, and it gave very immense support for the people working on it. There was Pipistrel at that time winning it, and Pipistrel is still the leading company in electric aviation. So let's see how Go AERO will go forward. You have to, okay, next one. Okay, and our next speaker is somebody who has been here at the show. He was actually showing his aircraft at the show for the first time. Backwards. Zurück. Noch eins. Okay, Michael Kügelgen with his company eMagic was showing us his manned version of the eMagic 1 2 years ago. He did win the e-Flight-expo prize, and now we're still looking for the first flight. While this, I continue a bit talking about his project, because seeing the market for developing such an aircraft, you also realize that electric aviation and eVTOL will come, but it most likely will not come with an air taxi. And that's why he will tell us today about his change to, now we are there, the Pelican eVTOL. You have it here on the screen as well. Okay, Mike, the stage is yours.
Thanks, Willi, for this introduction. And within the next few minutes, I would like to give you a overview where we come from. We will have a closer look at the development of eMagic 1 and the subsequent development of the drones. Everything started in the 80s or 90s when we developed unmanned air systems, so-called drones. At the time, nobody knows what drones are, and every time when I'm explaining that we are in the drone business, they thought we are producing honey or we are dealing with bees. But we had the MK105 Flash for reconnaissance and surveillance, and we also developed the attack drone MK106 hit, but we have been too early at this time. 80s, 90s, there was a reunification of Germany. The Soviet Union fell apart, and there was no longer an Iron Curtain, and there was the slogan, there will be no war on Earth anymore for the next thousands of years. This was the bad story for us, because we have been ahead of our time. But at the same time, it pushed me to start my own business and my own company, MK Technology, in the early 90s, and we are focusing on special machines, special equipment. Let's have a very short look, a very short video, what we are doing.
Flugzeugtriebwerke sind komplexe und hochentwickelte Produkte. Um das Fliegen immer leiser, effektiver und auch sparsamer zu machen, werden sie kontinuierlich optimiert. Dazu ist es erforderlich, an die Grenzen von Materialien und technischen Prozessen zu gehen. Beides erfordert Ingenieurskunst und Kreativität. Für eine höhere Leistungsdichte beispielsweise müssen Brennkammer und Turbinenschaufel Temperaturen aushalten, die teilweise über dem Schmelzpunkt ihres Werkstoffes liegen. Da man diese Bauelemente schlecht im fliegenden Gerät erproben kann, kommen hierfür spezielle Prüfstände zum Einsatz. Mit dem Hochtemperaturprüfstand von MK Technology hat das Grafschafter Technikunternehmen Herausforderungen gemeistert, die bisher unmöglich schienen.
Es gibt natürlich schon solche Teststände, aber die können nur Temperaturen bis 1300, 1350 Grad erreichen. Aber für die neuen Triebwerke braucht man wesentlich höhere Temperaturen. Wir fahren also bis 1800 Grad mit so einer Anlage. Und dafür braucht es spezielle Kühlung, spezielle Beschichtungen und vor allen Dingen, das war der Clou an der Sache, dass hier eine sogenannte Filmkühlung ausgebaut wird. Man sieht hier hunderte von kleinen Bohrungen mit Pressluft, wird dann von außen diese Luft da reingedrückt und sie bildet einen Schutzfilm von innen, der sich dann da anlegt und so die extreme Hitze nicht direkt mit dem Material in Berührung bringen lässt.
So leistet der Prüfstand einen Beitrag zu einem umweltschonenderen Flugverkehr.
Wir sind hier in Deutschland dazu verdammt, innovativ zu sein, denn wenn wir uns auf irgendwelche MeToo-Produkte zurückziehen, dann haben wir verloren. Und wenn wir dann anfangen, nur noch über den Preis zu verkaufen, dann gehen demnächst hier die Lichter aus. Wir müssen also neue Anlagen, innovative Technik liefern und wenn dann alle anderen das in 3 oder in 5 Jahren uns nachbauen, dann müssen wir schon wieder weiter sein.
So. You have heard this, and I just realized that I have obviously only this one single black jacket. This is the company MK Technology, and this is how we earn our money. We are an international company and traveling all around the world. And when COVID started, 2021, I had no longer work to do, and this is why I started remembering my old skills and designing my own aircraft. And like always, we started with a model, with a drone in the scale 1 to 2 to check the performance and the aerodynamics and the stall characteristics. You see, it's in front is a drone, in the background is a man-carrying aircraft. And when this has been accomplished successfully, we continued with load analysis and which material we should choose. We made negative molds with our friends from Silence Aircraft, Matthias Streecker and his brother Thomas Streecker. We continued with the carbon work, which is carbon honeycomb sandwich. We also developed our own electric motors for the lift, and in parallel we did the hovering platform to check the engines, the propeller and the complete flight control. We made a lot of very intensive testing, and by the end of the day we have been developed successfully the complete new aerodynamic design of this tandem wing, the lift engines, the propeller, the flight control and the battery management system. And let's have a closer look how this aircraft is flying and how silent it is. It's maybe 10 meters away from the camera. Throttled a little bit down. So this is engine switched off, gliding, and now engine switched on. So really silent, very forgiving, very smooth flying, perfect stall characteristics, like a tandem wing or like a canard. And the noise is coming from the brake, not from the engine. And the same in the hovering phase, because the 8 lifting motors turning with maximum 1500 RPM. So, based on all this experience and all this knowledge we collected, and because single-seater electric aircraft is not easy to sell, we were thinking about the next steps, and one could be a multi-seater with a twin engine, but the biggest market actually we see in the field of drones, and based on our aerodynamic concept, we designed a cargo drone
but also a rescue drone, the yellow one, with the following parameters, technical specs, can carry up to 150 kg based on our experience with eMagic 1. With a speed of 100 knots, there's a range of 150 kilometers and an endurance of at least 1 hour. If you are willing to reduce the payload, we can double this endurance. Again, we still see a lot of opportunities and big market. And if we are able to rescue only 1% of all the dead and injured people in traffic on the street, we would be able to save the life of at least 100,000 people each year, which is a very strong argument. And the same aerodynamic shape can be used, of course, for military purpose. We had this already with the Grille. Rescue wounded soldiers from the forward front line. And like always, we started with scaled down version of this model. It's twin engine again, because we have to open the nose for easier loading and unloading of the goods or of the wounded person. And it's no longer a tail dragger, it's a three-cycle gear, also for easier loading and unloading. And we designed this model, and last week we had the first test flight with my friend Willi Marshall, who was responsible for all the 3D printing development. And let's have a look. It's the maiden flight or the second flight, how beautiful this model is flying. In a very beautiful scenery as well. It's in Austria. Same stall characteristics, same flight performance like all the others before. Even aerobatics. Imagine there would be somebody in. And once again, the complete model was built with 3D printing. It was designed and made, let's say, within 4 weeks, 8 weeks, the total work. René? So this is one of the big advantages of the 3D printing technology, and inside it's reinforced by carbon struts. So this important milestone has been accomplished successfully, and right now we start with milling the negative molds for the big drone for the 6.5 meter model. And I'll keep you posted. Thanks a lot.
Thank you very much, Michael. And I'm sure somebody has questions, which we will ask later. Interesting thing, if you want to see the model, you also have it inside the hall A7. If you go to our booth, you see it there. Now we go to the next speaker, so we'll have some more time left. It's also a single-seated aircraft, but it's a totally different purpose, because now from Medivac over possibilities of cargo, we now have Pivotal showing us their aircraft which is flying, and you can buy it in the United States right now. So if you want to fly an eVTOL right now, you have to go to United States, and then you can buy it and you can fly it. Unluckily, only here at the moment. If you can fly it here soon as an ultralight, we will see. The stage is yours.
All right, thank you. So I'm Greg Kerr, I'm head of product at Pivotal, and excited to tell you a little bit about who we are, who Pivotal is, where we kind of came from, and our roadmap, so where we see our technology going, and then a little bit about our customers and the people who are flying right now. So this is a little bit of our flight footage, starting with a clip of me there. We entered the market last year with this aircraft, which we call Blackfly. So we are a light aircraft manufacturer in the United States, building this unique looking eVTOL aircraft. So a little bit about where we are today. if you can read that small text. So, like I said, we've entered the market now. We've been doing what we call an early access program with our Blackfly aircraft. So we've got a number of customers that we've delivered to who we're working closely with to really understand how they're operating the aircraft day to day. We have trained over 20 pilots. We've now accumulated 500 plus human flights. We've done thousands of unmanned flights. We've now delivered 8 aircraft to a defense subcontractor in the United States, and we're working away on our production model, which is Helix. So Helix is basically the scalable production successor to Blackfly. We've improved the power and propulsion, so we get an improved flight envelope, higher climb and descent speeds, greater density altitude ceiling. We've improved everything electrically around the aircraft, and we have designed it to be able to handle some new batteries when those become available. So this is generation 4 of our aircraft, and you probably wonder how we got here. Well, we started kind of humble beginnings. This was our founder, Marcus Ling, who built and flew what we believe was the first eVTOL at the time in 2011. And in 2014, he moved down to California after attracting the attention of an investor. We started working away on version 1, and so this is roughly the same scale of the new aircraft, but version 1 was really just to prove out our propulsion systems and our control systems. And after that, we started version 2, which you see here. This one had a single fuselage. It was the first one really designed to carry people. And in 2018, we did just that. We announced to the world what we were up to, and we did our first human flights and started learning a lot more about human interaction. And then on the heels of that, we started version 3, which is, you'll see it in a moment, it's kind of what is most recognized as Blackfly now. So this is version 3. It has a ballistic parachute, it's amphibious, it's been our workhorse for the last 6 years. We've done over 6,000 flights with it, 65,000 kilometers in total flown, and we've put it through all sorts of environmental testing and EMI, EMC testing. So where do we see this going? Well, I haven't talked about the architecture too much yet, so let's talk about that. It's unique in that it's a tilt aircraft. We don't tilt the wings, we don't tilt the motors, we tilt the entire aircraft. So all the propulsors are used in both hover mode and cruise mode, and you can control the aircraft continuously between hover and cruise and everything in between. So basically this is unparalleled in its simplicity. You have fewer moving parts, fewer failure modes, lower cost, and you still get the benefit of quiet and efficient winged flight. It's sort of like a tail sitter, but unlike a tail sitter, you can take off and land at a variety of pitches, so you're not subject to really strict wind limitations. It's very controllable. And we see this having a lot of potential beyond personal aerial vehicles. We're looking at cargo applications with a payload of roughly 100 kilograms. We're also looking at emergency response. You can imagine a trained medic trained to fly this aircraft, jumping in, they'll be up in the air in seconds. They can bring aid bags, blood, whatever they need with them, triage patients, and actually load one back in the aircraft. And do so, much quicker than traditional assets. We also are looking at rapid response firefighting. With the low cost of the aircraft and easy transport in a trailer, you can have a large network of these aircraft ready to go. You can have multiple up in the air and get to the source of a fire before it spreads. And in a defense scenario, as you can imagine, they're low noise, low observability, and you can actually team multiple together, have some piloted by operators, and some carrying cargo or waiting to return cargo. And all of this actually scales really nicely up to what we're calling a Gen 5 aircraft. Same architecture, it's roughly a 500 kilogram gross takeoff weight. And in a battery electric version of this aircraft, you could actually carry 2 people. Gives us a lot more space to do things inside the aircraft, even have someone lying down. And in a hybrid configuration, we could get our range up to 400 kilometers and 200 kilograms of payload. So that's pretty compelling. We see this architecture taking us a long way.
And underpinning all of that is safety. That also seems pretty hard to read, but you know, our philosophy is just pragmatism. We believe keeping it simple keeps it safe. We believe in pilot proficiency. We have a really well-developed training program that we're continuing to develop at this point to make sure everyone is proficient and operating safely and keeping current. And we have this advantage of thousands of unmanned flights being flown before ever putting a person in the aircraft, which traditional aircraft haven't really had. So all of that is backed up by data analysis, cloud services running all sorts of self-checks and predictive maintenance. And that all supports these smiling faces. All of these are either customers or employees who have taken to the skies in the last year with all this technology behind them. And with that, I'll just leave you with a quick video.
Thank you.
Yeah, thank you very much. I think it looks like a really fun toy. And would you have think 25 years ago that we would have such things flying? That you could even buy such thing and fly around? It really looks like coming somewhere from the future. Having this said, if you saw that several people coming in, coming out, which is always a problem here on the show because you have other appointments, you have to go. We are recording this and you have a chance to show it to friends if it was interesting in a YouTube video like we've done over the last 5 or 6 years here at E-flight-expo and other events we do. With this, I open it for questions. I have several questions already for you, so if anybody of you has a question, please lift your hand and then we can come to you. If not, I would start with the first question just with the last picture. I was seeing there in the video, the one taking off and landing on water. I think there is a certain story behind this water, because in the Part 103 rule, the water, land and takeoff capability has some special meaning. Maybe you can give us some.
Yeah, I can elaborate on that. So, under the ultralight category in the United States, which is Part 103, there's a maximum weight limit for the aircraft, but if you have amphibious capability, you get extra weight allowances for certain components on the aircraft, notably like amphibious fuselage and floats mounted to the wings. So that brings the total weight of the aircraft to 348 pounds, empty.
Okay. I have a question. Very interesting concept, congratulations, and you also sold the very first unit already.
That's right, yeah.
Yeah, perfect. What about the glide characteristic if you switch off the engine? Do you need the engine always running, or you can also glide?
You need the engines always running, so we've really taken the stance of building as much redundancy into the system as possible. 3 flight controllers, 8 motors. You can tolerate the loss of multiple motors, but ultimately you have a ballistic parachute.
Any idea to enlarge the wing area to make this possible?
Certainly looking at it, yeah. Like you saw with the larger, the concept for the larger aircraft, it would have extended wings and definitely different stability characteristics.
Especially for the drone idea, it would be ideal to have such a machine.
Yeah, agreed. Agreed.
So one thing there maybe to add, there is also, you need the motors also for control the vehicle, because there are no control surfaces, so if you want to control it, as I understand, you need...
Almost. There are actually 8 control surfaces. You still want the motors active, but the control surfaces on the wings
okay.
help a lot.
So you could... Okay, so next question maybe I can ask to Sky, because like, could you, because we don't have, just share. So if anybody, if you has a question, you raise a hand and I'll give you or get you the microphone. My question there would be, you have this competition. In this competition, would an aircraft like one of those which we've seen, could they compete in the competition? Would they have to be the inventor, or could I, for example, buy like it's not called a helix now, buy a helix and then compete in the competition? Maybe if I add some cargo system, or do I have to invent an aircraft myself for competing?
Yeah, so that's a good question. It is definitely one of our frequently asked questions, and the short answer is no. There are no restrictions in terms of who built it or when it was built or when it was invented or anything like this. So, and that's part of the strategy of the competition is you could start today to make something that is perfectly optimized and tuned specifically for this competition. But remember, the timeline is only a few years, so you're balancing the risk of development against something that's maybe a bit more competitive. And so if you already have something developed, as some people on stage do, then there is that advantage that comes from, hey, we'll be able to show up with something that works, but you may not be able to compete as well as somebody who develops something bespoke just for the competition. And that's one of the things that makes it interesting.
Okay, thank you. A question to the Avilus team. We've seen you have a relatively kind of simple model, which means it's a lift. It's not a lift and cruise. It's not a tilt rotor, not a tilt aircraft. It's a kind of enlarged drone. It's a multi-copter type of vehicle. Are you in your team also, or have you been discussing, and are you for the future also discussing maybe other solutions that they would say that would be the Mark II Grille, or maybe another name, which will be a lift and cruise aircraft, or any other design?
So the Grille is a point design to the requirements. It is an eVTOL, and we have the range requirements of, initially it was 20 kilometers, now we increased it to 30 kilometers of radius, so back and forth. So it fulfills this, so efficiency was never a problem for this specific use case. That's why there is no plan at the moment to change the configuration, at least for this use case.
Okay. Now changing the configuration, but this is a question then for everybody. Are you implementing that, you know, everybody's hoping and we're expecting battery quality is going to change. So we hope to have higher energy density batteries soon. Would it be easy to swap the batteries in your system? So if I would have the batteries with a double capacity like CATL is promising, 500, would you then could put it in and then fly 50 kilometers, or would the whole design has to be redone? I think everybody, if you start and then we go.
I think because for the Avilus configuration this is quite obvious. The batteries are on the lateral side of the aircraft, and the configuration is done like this, that you can easily plug them out by a person after the flight and put in new ones. So basically, if these new ones have twice the energy density, of course, then the range comes for free.
Okay, then maybe the same question to Mike. The battery in his configuration.
It's a very simple calculation. Right now, the aerodynamic flight is done by the front motor and 62 kg of batteries. If you double this size and the weight to 124 kg, we will also double the endurance to 2 hours. Or if we finally are able to have better performance batteries. We are all hoping for the last 10 and 20 years to get it.
Okay. And
yeah, I think it's the same story with us. Very modular design, easy to replace batteries in terms of maintenance, also swap out new designs, and electrically the architecture is compatible with a lot of what we're seeing on the horizon. But I think we're also sort of proving that we don't just have to hope for the new batteries to make something practical. I think all of us are actually building things that work and they're here now. So.
Yes. I have a question on the medical side. On the right-hand side, what did give you the motivation? So is it just an expectation that you think, yes, I think the soldiers should be faster in the under Kerr, so that's why I developed it? Or do you have a real base fundament that you speak with medical people, speak with the people who are going to use it in future, and that's, okay, if we can gain time, we gain lives?
Yeah, I think we have the expert here in the audience, Professor Bieberthaler from the Kliniks der Isar at Technical University Munich.
Yes, thank you very much, everybody. Okay, here's the camera. So please let me explain very shortly the development of this. So in the very first beginning, the developers of the aircraft came to me and asked what kind of requirements would be necessary to make this a life-saving equipment. And probably I have to explain very shortly the question. If you have battle injuries, which means penetration injuries, then the most frequent reason for death is bleeding. And so you have about probably 1 hour, 90 minutes time until you reach a surgical site where a surgeon, somebody who knows how to put a clamp on the vessel which is bleeding. And which means that this device is perfectly adjusted to this medical setting. So we do only several medical maneuvers before the patient is evacuated. And it's only those things which really have proven to be life-saving. We adjusted this to the American TCCC concept, which is a concept of the American Army. They do this already with conventional aircraft, but we transferred this to this specific device. So it's absolutely perfectly adjusted to the medical needs for us.
Okay, thank you. I have a question which is a very kind of selfish question of myself. Will I be able, do I have to travel to, like I said before, to United States, which I'm planning to do this year, to fly the pivotal helix? Or are you thinking also getting it being flying in other countries, maybe Germany?
Yeah, absolutely. So we're looking at a lot of different countries and jurisdictions right now, but I mean our presence here indicates how interested we are in getting ourselves flying in Germany and Europe in general. It's a complicated landscape. We're definitely focused on the US Part 103, but I'm confident we could do whatever demonstrations or test programs or provide whatever evidence is necessary as we meet the right partners and figure out what the path is. So I'm excited for it.
Okay, another question to you, which is a little bit what Max said before. I would like to have the answer also from Michael. What about the redundancy in the aircraft? How much redundancy you have? Like if I fly with your aircraft, if I cut off one propeller, or if one propeller is destroyed by a bird cut off, it still keeps on flying, I suppose. What when you lose two propellers?
Yeah, it depends on the configuration, depends on which two. I mean, we actually, if you lose one, the system can rebalance and throttle things back on the other side. And we're actually looking at increasing spacing and kind of doing studies to figure out how to mitigate the risk of losing two. But yeah, we can tolerate any single failure and certain configurations of two failures.
Okay, Michael, what was the with your aircraft with the
redundancy?
Yeah.
To be honest, we are quite to the limit, and if from the 8 hovering propellers one will fail, we have a problem. This is why we did it not in higher altitudes, but in maximum 5 meters.
Okay, so you're working on stronger motors, or what?
Yes, this is our actual development, stronger motors, because it controls high efficiency props, and so on.
Maybe a question to the grid. I think you mentioned this, that you can lose one prop, but can you also lose one arm, where you have, let's say, 2 props on the same position, which you would lose?
So you can lose one battery pack, you can lose one engine, you can lose an arm, doesn't matter.
A whole arm with 2
would also work.
Okay.
That's also the reason for the multi-copter.
And you also have a rescue system on board of the aircraft, or like a ballistic rescue system?
We do have a parachute system on board.
The question is always under which conditions are you losing one engine? Is it fully loaded, maximum payload, gusty wind, 3 to 4 Beaufort, or it's an empty weight? This has to be discussed and have to have a closer look at this. There is not a general answer, yes we can do it, or no, sorry, we can't.
Okay, I have a question to Sky. Your pre-competitions you're going to start. Will it, we could see of the supporters you have, there are supporters from around the world for the Go AERO. Will be the pre-competitions and the evaluation also happening in other countries or United States only?
So if you look at the rules, that's one of the reasons that everything is not in SI units, is that it will be a United States hosted competition, so that final fly-off will be in the US. And so this is kind of another reason that it's helpful to say everybody has to have an aircraft that can be made compact to make it not as big of a disadvantage to ship the system to the US for the competition. But yeah, there is, for those first 2 stages, there is no need to travel or go anywhere for proving in that second stage that you have a prototype that works. That's just through your own videos that you submit, so there's no need to travel. But it is for that competition. It is an event where everybody comes together and competes head to head.
I have a quick question for AERO. Why set the dummy's body weight at 57 kg? Because it appears to be lower than the average body weight by FAA, like 75 kg.
Yeah, so it's a less than 60 kilogram dummy. So this has a lot of reasons, and it's complicated. We acknowledge and we own that is about half of what you would need for a practical single occupant vehicle, especially in the public good mission space. It's usually not just a person who you can always rely on being a relatively lightweight person, even if that person is lightweight. If they're an emergency medical technician, then they need a lot of equipment with them, for example. So the 125-pound payload is a couple of things. One, it lets teams that are developing vehicles from scratch develop the smallest thing possible that is still plausibly scalable to a practical 1 or 2 occupant vehicle in terms of the technologies and configurations used. It's also from the practical point of view of running a competition. Once you start getting to be, if you say, okay, we want to use 250-pound or, maybe even 100-kilo mannequins, then now just moving them around the competition is very difficult, and now you need, instead of 2 people who's able to load these, because they're not ambulatory, so just loading and unloading, and some of these loading and unloading tasks are part of the missions themselves, becomes now you need 4 people instead of just 2 people. So there are a lot of reasons to go a little bit smaller than practical. And then, as I was saying before, it also adds an element of making the competition a bit more interesting for those who already have a system developed for something else versus those who are designing specifically for the competition, because they're able to design something maybe a little bit smaller, a little bit more advantageous if they're designing specifically for the competition, because they only have to use that smaller vehicle.
Final question, perhaps, just for Avilus. For the safety and the reliability, so for Medivac used purpose vehicles normally, what do you think about the safety and reliability? Because in order to save people, you've got to be safe yourself in the first place. So do you think that this Medivac drones needs to be have a very high level of reliability? Do you think it needs to be like AC eVTOL, the EASA AC eVTOL level kind of reliability, even 10-9 or even same bar? What do you think about that? I think the shorter question is that do you think the Avilus, the Medivac drones needs to reach a very high level of reliability and safety?
So at the moment the aircraft is flying in the specific category. At the target sail level there is sail 4. But of course, we can also talk about the certification specifications of light UAS or UAS whenever they are out.
Okay, thank you very much, and thank you for being here. I see that, and we see it here, that the next panel is already ramping up. Thank you very much again for being here. For you in the podium, if you missed the beginning, if you have any questions, anything, first, we have a recording. Second, you can contact Kerr directly. Third, you will find all the presenters here also later in the hall, so you can ask some questions in the H7 hall. And by the way, we will have on Saturday some electric aircraft flying here, if weather permits, but it seems to be getting a little bit better. So if you want to see electric aircraft in the air, we don't have eVTOL this year, but I hope next year maybe we'll have one or the other flying as well. And so with this, thank you very much for listening, and hope to see you. The next session will be on fixed-wing aircraft tomorrow at 11 o'clock, no, 10 o'clock. Then we will have a session in the afternoon on hydrogen, and we will have several short presentations on battery technology and on air traffic control on Friday. So stay tuned. You'll find the program on the AERO website or in our program here, the E-flight journal. You can grab one, which they are here in the front. And thank you very much. Thank you for coming. See you soon.
How can you receive E-flight journal? Just scan the QR code on the cover or on the promotion postcard or on the back side of the promotion postcard, or type www.e-flight-journal.com in your browser. And you receive the up-to-date blog site with the latest information from the world of electric flying, or click on the top page and you receive the latest version of the PDF magazine, either to read on your computer or cell phone directly, or click on the link below, and then you can download the PDF of the magazine as an offline magazine to read anywhere you want, even without internet connection. Thanks and goodbye.
Okay.